Welcome back to our lecture. The first topic I want to address is deployment pipelines. What is a deployment pipeline? Well, a deployment pipeline is a common pattern that we use to manage the deployment and testing of software in our organization. We will take our software code and send it through a set of different validation stages whenever there's a code change that takes place in the organization. And the idea is that as our code progresses through the pipeline, we gain greater assurance that our code is ready for deployment and release into a production environment. What are some of the benefits of a software delivery pipeline? Well, the key benefit is that the software is automatically built and tested throughout the different stages in a pipeline. And the idea behind continuous delivery is that we're always trying to produce working software that can be deployed into a production environment at any time. In a software delivery pipeline, because it is automated, it makes it easier to make changes to our software applications, because every single time that we make a change to our software application code, that change is going to be tested the same way. It's going to go through the same pipeline process on its way to a production environment. It's easier to automatically make this sort of progression through the pipeline versus trying to manually test our code and manually promote our code throughout the pipeline. And back in the day, most of these things were done manually. You'd do a manual build, and then you'd have manual testing processes. Then you would manually deploy the software into a particular environment. And anytime you have these sort of manual stages, there's always an opportunity to make mistakes. It's generally not a very reproducible sort of process. And so automation is really the key. And because we can push our code through the pipeline rapidly in an automated fashion, that helps to reinforce this idea that we should be working in small batch sizes, leveraging processes like continuous integration and continuous delivery. The other key benefit of a software delivery pipeline is that it greatly improves the compliance and the governance tasks within the organization. And this can be a really key area for organizations that have to deal with a highly regulated environment. Companies that might be financial organizations or healthcare organizations, they need to provide a granular level of traceability in their code and in the changes to their code. So a software delivery pipeline is able to provide that level of traceability, because essentially every single code change is going to go through the exact same automated process. There's less of a potential for not only introducing human error, but also less of an opportunities for humans to be involved in the promotion of code, where human beings at times can make poor decisions. Like they might promote code even though it's exhibiting some sort of regression defect, or maybe even maliciously, you'd have a human being that's inserting malicious code into the software delivery process somehow. That becomes far more difficult if the software delivery process is completely automated and managed by machines. Now, in the real world, you have oftentimes you'll have engineers which are completely focused on building out software delivery pipelines. Different companies call these engineers different things. Sometimes you'll hear them referred to as software delivery engineers or release engineers. They could be build engineers or CI/CD engineers. There's all kinds of different titles that are out there. But traditionally, you would have people that were sort of dedicated and focused on pipeline development work. But increasingly, what you'll find is that in many organizations, the software developers are also partially responsible for the build pipelines. In my own organization, the different development teams actually do a lot of the software delivery pipeline work themselves. And then there are people like me and others within my team who are able to mentor and guide software development team members when they encounter, trouble when building out their various pipelines. Okay, well, let's start looking at sort of a basic software delivery pipeline. Now, every pipeline is a little bit different, and it's going to depend on the type of application that needs to be deployed. It's also dependent on the organization to a certain extent. Again, you'll have some organizations which might be working in highly regulated industries, and they might have some special needs in terms of pipeline stages that they create. You could also have other organizations where maybe they're working on an application which is absolutely mission critical, and so they'll need to introduce more testing or performance testing stages to their pipeline. So the sort of the general pipeline I will present in this lecture represents the kind of a very basic sort of pipeline that you might encounter. And in the real world, our pipelines would generally be a little bit more elaborate. But the sort of general stages would remain the same. We might just have more testing stages in a real world pipeline. Well, our basic pipeline design begins with some sort of local development stage. And this is a stage where developers are building and testing software on their local workstation. And they might be writing software code natively, or maybe they're using HashiCorp Vagrant and some sort of virtual machine. Maybe they're even building it inside of a Docker container. But the point is that they're building and testing and writing unit tests locally on their workstation. And part of that process involves, as I mentioned, writing unit tests, which are these functional level tests that will rapidly test small modular pieces of the software code. And those unit tests are generally written by the software developer. The software developer could also be linting their code locally. And linting is a static code analysis process which will help the developer identify any sort of syntax or even a software syntax style defect within their application code. I always strongly recommend that software teams lint their code because it will help to ensure that all of the team members on the software development team are complying with a sort of a standardized way of building their software code. They're all conforming to a similar style of software coding. So these two steps, besides obviously building the software code, they'll be writing unit tests, they'll be linting on their local workstation. And then they will check their code, they'll commit their code into a version control repository like Git, and they'll push that code into the centralized Git repository that's hosted in a location like GitHub or Code Commit. And when that happens, when they commit their code and they push it up to the centralized repository and create a pull request, that will then trigger the build stage in the pipeline. And this is oftentimes sort of the first visible stage, the first automated stage of the software delivery pipeline, this initial build stage. And during the initial build stage, what will happen is that the build system will create a build environment where it will essentially download those code changes. It will clone that GitHub repository and pull in the changes that the developer committed to the repository. The build server will then go through a sort of a process whereby we'll lint the application code. It will perform unit tests on the application code, and then then based on, depending on the type of application, it may actually go through some sort of compilation process where it will actually build some sort of binary file. And that binary file, or any of the files that result from this build stage process, these files represent artifacts, output artifacts. And the output artifacts will be packaged and stored within some sort of artifact repository. They're not going to be stored permanently on the build server, because the build server is sort of ephemeral. Typically, after it's done building a project, then it kind of just goes away. We want to take those output artifacts and store them in some sort of repository. And, this is where they're typically going to be versioned, and there's some traceability back to the original commit that triggered the build process. The artifact repository could be something as simple as an S3 bucket. It could be an actual commercial artifact repository, a server like Artifactory or Nexus. But the key is that the artifacts are stored somewhere. Now, after the build stage, we have these output artifacts. Those output artifacts then are going to be deployed into some sort of testing environment in the next stage called the testing stage. And this is really the first time where we're going to take those output artifacts, that new code, and we are going to deploy it somewhere. And this is a great opportunity for the pipeline to exercise the application deployment process. We want to deploy our application a number of times into a number of environments before we ultimately deploy it into the production environment. We want to make sure that we're using the exact same process that we're going to use in production to deploy our application into a testing environment. So we deploy the code artifact into our testing environment, and then we initiate a set of automated API or UI tests to run against that environment. And our goal is to test the integration of our software with other services within our platform. And we may also do some end-to-end testing as well, using a UI testing framework, something like maybe Selenium. And we're going to, test some of those key workflows through our application platform. We also may the testing stage might be broken up into a set of testing stages. The first one, maybe we're going to do some integration level testing, more automated API testing. And then a second testing stage could be non-functional testing, where we are going to do some resiliency sort of testing, We could implement some performance testing, and we could simulate customers accessing our application and steadily ramp up the scale of customers accessing the application to see if our platform is still performant. We may also do some manual testing. That's still very common. It's pretty rare to find a software delivery pipeline which is 100% automated. Typically, there's at least one stage where there are some manual tests performed, and once those manual tests are performed and everything checks out okay, then somebody clicks a button, and that basically sort of resumes the automated pipeline. So, a manual testing stage is pretty common. Well, after our testing stages have completed, then we will continue to promote our code. It will promote it into typically some sort of staging environment. And so we'll take that code artifact, those code changes, and we'll deploy them into a production-like environment, typically a staging environment. We'll also then initiate a set of automated smoke tests to run against that environment. Smoke tests are a simple set of tests to validate that the key functionality in our software platform is still working properly. It's just a quick way of gauging whether or not our platforms is still working. The automated testing suite could be, in prior stages is generally much, much more rigorous, and in where we might perform hundreds, maybe even thousands of tests. The smoke test is just a quick way to validate that the deployment process is working properly and our software is working. After deploying into our staging environment, if everything looks okay, then we can think about deploying our software into the production environment. And again, we're using the exact same deployment process that we followed in all of the previous stages. So we have a very high level of assurance that our deployment process is going to be working properly by the time we deploy into the production environment. And also recall that just because we deploy our software into the production environment does not necessarily mean that our customers can begin using the new features and new code. Hopefully, we're leveraging patterns like feature flagging so that we can decouple our software deployments from the release of our software to our customers. This diagram kind of depicts a typical software delivery pipeline process. And on the top left side, you have a developer checking in their code into a version control system, something like GitHub, and that's going to then automatically, via a webhook, trigger a build process on our CI/CD system. This build process, in this example, the build process is red. If there's some sort of failure there, and which is great because it provides quick feedback to the software developer that checked in their code. And the software developer can look at that build to try to understand why it failed. They can make changes to their code, check it back into the version control, and that triggers then essentially a new build pipeline. And that process will trigger a new build, and that build works. The build then progresses to the next stage, which is the automated testing stage. And in the automated testing stage, the build fails for some reason. So it's some test failed. And again, it provides feedback to the developer. The developer can then fix the code, check in code again, and this time it will pass the build, and then it will also pass the automated test. gets up to the user acceptance test stage where there's a manual approval process. That manual approval is granted. And then the software gets to sort of a release stage where it might be deployed into a staging environment and then ultimately the production environment. You can see that the software code has got to progress through all of these stages from left to right. And along the way, there might be failures, and those failures result in feedback to the software developer. The developer can make changes, and then the process begins all over again. One thing to keep in mind here, well, actually a couple things to keep in mind. One is that you see that if there's some sort of failure, the process is sort of kicked back to the developer, and then the pipeline begins all over again from the very beginning. The pipeline never resumes from a failed spot. It always starts from the very beginning, and that's absolutely key to implementing this pattern properly. You would never, ever want to restart the pipeline from a stage in the middle of the pipeline. The pipeline always restarts from the very beginning all over again. Again, this is providing us with that traceability. Every single change has to go through the exact same process from left to right through all of the stages in the software delivery pipeline. And the second thing to keep in mind is that when we produce output artifacts from something like the build stage, those output artifacts are promoted through every subsequent stage in the software delivery pipeline. We are never, ever rebuilding our software. We build it once in the build stage. We don't go and build it again in the automated testing stage or in the, when we're right before we're about to deploy into staging or production, we don't rebuild the software again. We'd never, ever, ever do that. We build our software once in the software delivery pipeline, and then the resulting output artifacts are promoted from each stage of the pipeline into ultimately the production environment. And that prevents us from introducing a slightly different build in different stages of the software delivery pipeline. So this delivery pipeline, there are a number of practices, and I mentioned a couple of them, but essentially the goal of this pipeline is to prove that our software changes are production ready and that we're able to release our software at any given point in time. We only want to build our software binaries once. We only want to have one set of output artifacts that we build at the initial part of our pipeline, and we'll promote them through every subsequent stage. And every single time that we make a deployment within the pipeline, we want to deploy it, our application code, the same exact way. We want to use the exact same deployment process, the same deployment shell script or Python script, or however we've designed our software deployment process. We're following the same thing, same process every single time, every single stage. By the time we get to production, our software code will have been deployed at least a handful of times, and so we'll feel very confident about the deployment process. And if any part of our pipeline fails, then it's incumbent on the team that owns that particular service or part of the platform. It's incumbent on them to sort of swarm around the problem and make every effort possible to fix whatever the issue is. It's not just the responsibility of an individual software developer if a pipeline fails. It's the responsibility of the entire team that owns that particular service to figure out why the pipeline is blocked and to remediate that particular situation. One other thing I want to mention in this section of the lecture is that oftentimes when we are building software components using these pipelines, we might, we'll leverage some sort of fan-in pipeline pattern. And the idea here is that we might have like a a larger sort of platform that we're building, and that platform consists of a number of smaller components. These could be smaller services. We could have separate pipelines for each individual service, and then the output from those pipelines, the resulting service, is then going to be assembled along with other services in a sort of aggregation pipeline that will ultimately assemble our entire platform. This is a very common pattern that you'll find in organizations that have implemented software delivery pipelines.